Find the solution to the initial value problem. We're given y double prime of t is equal to 10t e to the t, y of 0 is equal to 6, and y prime of 0 is equal to 1. Okay, so the first thing we're going to do is integrate both sides of this equation here. When we integrate both sides of this equation, since this is the second derivative and we're taking the antiderivative, it becomes the first derivative. Okay, equals 10t e to the t dt. Okay, so now we need to figure out what this side is. And you may recognize this. This is going to be a integration by parts. So the formula for that, if we have u dv is equal to uv minus the integral of v du. So we need to figure out what our u is and what our dv is, and then we can figure out du and v. Okay, so we're going to pick our u to be 10t, and the reason for that being is because when I take the derivative of 10t, it becomes a 10, so the t goes away. The same couldn't be said if we chose e to the t. So we choose e to the t to be dv, and if you take the antiderivative of e to the t, it's still e to the t. Okay, so I'll write this over here. We have the integral of 10t e to the t dt is equal to v du, so v du, or excuse me, uv. uv is 10t e to the t minus, let's see, v du, which is the integral of 10 e to the t dt. Okay, and if we go a step further than that, we get 10t e to the t minus 10 e to the t plus c1. Okay, the reason I'm writing c1 instead of just c is because we are going to have multiple c's in this problem, and they're not necessarily the same c value. Okay, so we put this over here. Y prime of t is equal to what we wrote over there. Just rewriting it here. Okay, and now we're going to use the information that we're given. We have y prime. We're given that y prime of 0 is equal to 1. Okay, so I'm going to plug in a 0 in for t and set this equal to 1. So 1 is equal to 10 times 0 e to the 0 minus 10 times e to the 0 plus c1. This goes away. 1 is equal to, this becomes 1, so negative 10 times 1 is negative 10 plus c1. So c1 is equal to 11, which gives us y prime of t is equal to 10t e to the t minus 10 e to the t plus 11. That's our derivative. We started with second derivative. Now we've worked out our derivative. Now we need to go one step farther and figure out what the original function was. So again, we're going to repeat this process. The integral of y prime of t plus, or equals, the integral of 10t e to the t dt plus the integral of negative 10 e to the t plus the integral of 11. Okay, and that's all dt. I forgot to write my dt's there. Okay, so this becomes y because it's the derivative and we're taking the antiderivative, equals, this one we've already figured out, and this one we've already figured out, okay, early in the problem. So we look up here, say, okay, we've got this is equal to this. We don't need the c yet. We'll write that at the very end. So on the first, this one, we get 10t e to the t minus 10 e to the t. Okay, that takes care of the first integral there. And then on the second integral, we've already done that one as well. Negative 10 e to the t, we did it in this step right here. Okay, but we also can just look at it and say, okay, well, e to the t is its own antiderivative. Negative 10 is a constant. So it's another negative 10 e to the t. And then 11 is just 11t plus c2. Why did I write c2? Because it's not necessarily the same number as c1. Okay, so we differentiate that way. So now we're going to use, just like last time, we used this number. This time we're going to use this number. Plug in a 0 for all the t's and set it equal to 6. So 6 is equal to 10 times 0 e to the 0 minus we can combine these if we want. That's 20. So minus 20 e to the 0 plus 11 times 0 plus c2. This one goes away, this one goes away, and this one becomes negative 20. So 6 is equal to negative 20 plus c2, so 26 is equal to c2. Okay, that's important because we can now write that in place of this, and we get our final answer. Y of t is equal to 10t e to the t. I'm going to combine these two together to make a negative 20. 20e to the t plus 11t plus 26. And that is it.